Hello students, welcome. So in this Cube live session, we are going to start with a very new topic and discuss a very important concept here, that is transformation of graph. I hope you have seen something like this earlier also. So we will start from basic and we will try to understand what it is all about. So basically when you talk about transformation of graph, a graph is given to you and that graph is being transformed. Either it transformed right or left, that is called its shifting, or it can transform upside or downward, keeping the size and shape same, that is vertically or downward, or its shape may change, size may also change, while it may shrink or expand horizontally or vertically. So there are many cases like this and you have seen those cases earlier also. I will explain to you all such cases and I will also explain to you how you will transform one graph to another graph. So let us see a function here f of x, and that function I am taking here fx is equal to x to the power 4. Now this is a graph which is normally we see is a graph which is like this. This is similar to x square. So x square is so common, I am taking x to the power 4. It is more steep. So this is fx is equal to x to the power 4. Now in this graph, if it is been asked to you that suppose I change its equation from fx is equal to x to the power 4 to some other equation. Let us suppose I am taking it as gx is equal to x to the power 4 plus 2. So what will happen to this graph? Right now you have this graph like this and this is the axis, x and y axis. So the graph will vertically shift upward. So how will it vertically shift upward? The graph would be something like this. This is the graph and in the next step it would be like this, and this point will become 0, 2. That is, the graph has shifted upward by 2 units. Why it has shifted upward by 2 units? Because we have added 2 to x to the power 4. Right students? Now how all these concepts work? Is there some logic behind it or such? We have to just remember something like this. So there is of course a logic. If we understand few important concepts like y is equal to fx plus a we are doing, then if a is positive, then we have to shift the graph upward. The graph will shift upward, of course, as we have seen in the previous example. Why it is so? Because as you know that when you put x is equal to 0 here, you will get 0 to the power 4, f of 0 is equal to 0. So this point is the origin, right students? This point is the origin here. Now if you put 0 here, then 0 to the power 4 plus 2 at g0 is equal to 2. Not it is 0. So it is 2 here. At 0 it is 2. So at 0 it is 0, at 0 it is 2. That is why it has shifted upward by 2 units. Now this is the same thing which is happening here. If you put the value of x something, not only 0, any other value, you can put x is equal to 1, you can take x is equal to -1, any number in its domain, then it will shift upward. Now if it is y is equal to f of x minus a, and again I am taking a as positive, what will happen? Can you tell me students what will happen? Will it shift right, left, downward? Upward case we have already seen. So it will shift downward, of course. It will shift downward like this, right? Now what are the some other cases which we can see here? So if we see the lateral shift either right or left, horizontal shift which you can call. So what will happen? That in that situation y is equal to f of x plus a. Now here again I am taking a as positive. So it will either shift horizontal or horizontally right or left. Can you tell me it will horizontally right or left? Yeah, just think about it. So what will happen? It will shift to the left, not right but to the left. And if it is, I will give you an example here that will help you to understand it. Y is equal to f of x minus a, and a is positive. then it will shift right. So again I am taking you and giving you an example, y is equal to mod of x. Do you remember the graph of y is equal to mod of x? This is the graph of y is equal to mod of x, right? It is having a corner point at x is equal to 0, y is equal to 0, like this. And this is mod of x. Now if you want to write y is equal to mod of x minus 2, what would be the graph? Will it shift right or will it shift left? So what we have studied right now, that it will shift right by 2 units. So we will shift it right by 2 units and our graph would be something like this. This is 2 here and this is parallel to this. This is parallel to this, and this is the graph of y is equal to mod of x minus 2. If I take the graph of y is equal to x plus 3 mod, what will happen? It will shift to the left by 3 units. So it will shift to the left by 3 units like this, here and here. So this is minus 3. So this is how it is shifting horizontally, right or left depending. So why it is happening? So just you can see that here when x minus 2 is equal to 0, x is equal to 2. So that is why the point x is equal to 2 is the point where you are getting y as 0. Y is equal to 0 if x is equal to 2 here in this situation. So at x is equal to 2, y is equal to 0, whereas in the original one, in mod x, when x is equal to 0, y was 0. Here when you take x plus 3 is equal to 0, x will be equal to minus 3. So the corner point is now minus 3. So this point is minus 3 here, where it is changing its nature. So this is how it is shifting horizontally. So how do you remember this? Vertical upward, vertical downward. If you are adding or subtracting some value, some positive value, right or left. So for left, you have to add some positive value to the input. For right, you have to subtract some positive value to the input. So there it is a very important thing, input and output here. X is the input and fx is the output. So when you add something to the input, that is you add x, something a which is positive to x to the input, it will shift to the left. If you add something positive to the input, it will shift left. If you subtract something positive from the input, it will shift right. And if you add something positive to the output, that is fx plus a, then it will vertically upward. If you do fx minus a, it will be vertically downward. So this is what you have to remember regarding transformation of graphs. Now there is something else also. What is that? If you take, as we discussed earlier also, that there may be shrinking also, shrinking horizontal, shrinking vertical, expansion horizontal, expansion vertical. So what we will do in such situation, that if we have a graph y is equal to f of x, and right now I am taking a graph, for example, sin x graph. Sin x graph, trigonometry you have all gone through. So this is 0, this is pi, this is 2 pi, this is 1 here, this is minus 1 here. So this graph of sin x is known to us. Now if you do one thing, that write the equation y is equal to sin 2x, what would happen to it? So in such situation, as we were doing earlier, here also we will do the same thing. What you have done, to the input you have multiplied 2, not to the output, not to sin x, but to x, which is the input. So what will happen? So if 2x is equal to pi, here it is pi, then x is equal to pi by 2. And when 2x is equal to 2 pi, then x will be equal to pi. And if x is equal to 0, 2x is equal to 0, then x is also 0. So considering such situations, if we equate this input with this point, with this point and with this point, we get the final value of the input of the transformed graph. So what will happen? The transformed graph would be something like this, of sine 2x. So here it is a graph of sine x. Now we are drawing the graph of sine 2x. So the 0 is 0 as it is, and when you are taking x is equal to pi by 2, so this pi will become pi by 2 here, because when 2x is equal to pi, x is equal to pi by 2. So this would be like this, and then 2 pi will become pi like this. And when you draw the graph would be something like this, that it will go in this manner. So it has shrinked. What it has done? It has shrinked itself, as you can see clearly. So in the same graph, if I will plot both the graphs, it would be something like this, that here it would be like this, and this point has come here, this would be like this. So this is the graph of sine 2x, whereas the white one where is the graph of sine x. So as you know that this point would be pi by 2 here. So you can see clearly, cross check also, you can verify also that when you take x is equal to pi by 2 in sine 2x, when you put x is equal to pi by 2 in sine 2x, it will be sine 2 into pi by 2, which will give you sine pi, which is 0. So that is why in the transformed graph you are getting sine of 2 into pi by 2 as 0. So what is the conclusion which we are getting here is actually that when we multiply something to the input of the actual graph ax, considering that a is greater than 1, because if you see the previous graph, a is actually 2, so which is greater than 1. So if you multiply to the input something greater than 1, then what will happen? It will shrink by a times. Earlier it was shrinking 2 times. If you multiply by 3, it will shrink 3 times. So as you can see here, this graph has got half of what it was earlier. So it will shrink by a times. And then another point here is, if it is f of x by a, so we are talking about the original graph y is equal to fx. With respect to that graph we are talking about here. So with respect to that graph, the new graph will shrink by a times. If you will take a less than 1, greater than 0, it will shrink. It will not shrink, rather it will stretch. It will stretch a times, and it will be vertical or horizontal. As we saw earlier, it is horizontal. So keep in mind it is horizontal here. So don't confuse that it is vertical, it is horizontal. So as you can see here, that if we multiply the input by some value which is positive and it is greater than 1, then it will shrink by a times horizontal. And if the input is getting multiplied by a, let me correct it here because I have here divided also and taken a less than 1 also. So keep in mind here that this is f of ax. Both the places we have f of ax. What we are doing here is, we are just changing the condition on a. So I am not changing the function, I am changing the condition on the input which is getting multiplied with the a. So the a is greater than 1 here, a is smaller than 1 here. So I will give you an example of getting stretched also in the same situation. So here if I take you to the graph of y is equal to sine, I am taking yellow color here, so you can understand that the new graph which will be plotted will be from yellow color. So sine x by 2 if I am talking about, what will happen that this graph will actually stretch 2 times. So the new graph would be like this, this goes like this till here, and this further portion will go like this till here. So this will be the whole graph, that is this, the last point here is 4 pi, and the upper limit is 1, lower limit is -1 of the output, that does not change, but the input is affecting the graph. So this is how you can see the graph of sine x by 2. Now this three patterns will let you understand how the graph gets shrink or stretch horizontally. What about vertical shrinking or compressing? So if we talk about vertical, so in that situation again we are talking about the output. So graph is y is equal to fx. Now if we multiply 3 to fx, what would happen? So let me multiply 3 to the function fx and see what would happen. Now I would take a function here and I will take a different function here. Suppose I am taking e to the power x. We already discussed about an algebraic function, x to the power 4. We already discussed about a modulus function, and we have already discussed about trigonometric function. So now I am talking about the exponential function. So exponential function is e to the power x, whose graph is like this: y is equal to e to the power x, and this point is 0, 1, where it is intersecting the y axis. Now if I am talking about the graph y is equal to 3 e to the power x, what will happen to that? So what will happen? The output is getting multiplied with 3, so it will stretch vertically 3 times. So what will happen? That when you will take x is equal to 0, you will get y is equal to 3 into e to the power 0, which will be 3, because e to the power 0 is 1. So this is 0, 3, and the graph would be finally something like this. Here it goes like this. So it still is the exponential graph, but it is more steep, as you can see clearly from here, because the output is getting multiplied with 3. So it got stretched 3 times vertically. Now if we divide by some value, suppose we take 1 by 2 e to the power x, and we try to understand what is 1 by 2 e to the power x. So this graph is 3 into e to the power x. Now I am talking about 1 by 2 e to the power x. So that means it will get compressed vertically. So it would be something like this. It is going this way. So this is the point 0, 1 by 2. So this is how we can understand here. Now can we write a final result about vertical stretching and vertical compressing? Yes, we can write. So the first point here is, if we take y is equal to a times f of x, where a is greater than 1, then what will happen, students? A stretch vertically by a times. And if I take y is equal to a f of x and a is less than 1, greater than 0, a stretch horizontally, sorry, vertically only, but it will not stretch, it will compress. What will happen? It will compress vertically a times. So this is what is happening. If you multiply a quantity with this, which is positive, then and it is greater than 1 to the output, then it will stretch vertically. Otherwise, if it is less than 1, it will get compressed a times. Now, what are the some other specific situations? We have many more things to do in graphs. We can't go in so much of details right now. There may be transformation, stretching, horizontal, vertical, as well as many other things where it is involved at the same time. For example, you may get a situation where it is asked what is the graph of f of 2x plus 5 into 3. So how would you draw the graph of this one? Here what is happening? To the input you are multiplying 2, then adding to the final input, and then to the output you are multiplying by 3. So there are 3 operations happening here. How can you do that? So in that situation, if you know the graph y is equal to f of x, suppose I am drawing a random graph, not a known graph. I am taking a graph like this, and like this. Suppose this is 3, this is 2, this is 0, this is minus 1, and this point, this is a parallel line, suppose, and this point is 2, and this point is 1, and let us take this as 2 again. So this is the graph we have. In this graph, if I am asking you to apply this transformation, how would you do that transformation? So some basic steps which you have to remember here is, For the input, what we were doing earlier, if you try to understand, for the input, what we take generally, we talk about 2x plus 5. So 2x plus 5 is the input, the new input. So 2x plus 5, let us equate to all those points where the graph nature is changing. So first is minus 1, next one is 2, next one is 3, because from minus 1 to, yeah, from here it is one more point 1, so you have to equate with 1 also. So minus 1 to 1 it is just 2, from 1 to 2 it is this line, and from 2 to 3 it is this curve. So how many points we have? 1 point, 2 point, 3 point, 4 points of concern here. 2 points are the beginning points and end points, and intermediate 2 points where the point is getting change, the nature is getting change of the curve. So if you equate this input 2x plus 5 with minus 1, with 1, with 2, with 3, what are you getting x as? Can you tell me what is the value of x in these three situations? Yes, you can of course say here you will get minus 1, minus 5, minus 6 by 2, that is minus 3. In the next situation, what we will get? 1 minus 5 minus 4 by 2 minus 2. Here what you will get? 2 minus 5 minus 3 by 2. And the fourth situation, you are getting 3 minus 5 minus 2 by 2 minus 1. So this is the input, the new input which you are getting. Now after doing this, what is happening? That the graph is getting multiplied with 3, vertically it will stretch 3 times. So the new graph, if you will talk about, I am first drawing the intermediate graph, then I will find the final graph. So the intermediate graph would be here, something like this, that we have a point x is equal to minus 3 here, and a point x is equal to minus 2 here, a point x is equal to minus 3 by 2 here. So minus 3 by 2 would be here, a point minus 1 here, which is this one, and here what will happen, that the graph would be from minus 1 to 1 would be the nature of minus 3 to minus 2. So minus 1 to 1 is from minus 3 to minus 2, like this. Then 1 to 2, this line slope, having some slope 1 to 2. So 1 to 2 is minus 2 to minus 3 by 2. So this will go like this. And then it will be 2 to 3. So minus 3 by 2 to minus 1. So 2 to 3 is minus 3 by 2 to minus 1. So that would go again like this. So this is the graph. What you observe here, that it is almost having the same shape, same nature, but its size has changed. What is it? It has slightly shrinked. What happened? It has slightly shrinked. Why it has shrinked? Because you are multiplying x by 2, which is a value greater than 1. So obviously it will shrink. And then you are adding 5 to it also, to 2x. You are adding 5. So what will happen? You will expect that it will shift towards left. By how many units? So as you can see, it has got shifted left by, as you see here, it is shifted left by 4 units. As you see here, 3 point has come to minus 1, and the minus 1 point has come into minus 3. So it has shifted this much. So if you see here, not like that, actually if you can see here, it has shifted minus from here 3 to minus 1, and then minus 1 to minus 3. So of course it has shifted also and shrinked also. Both is happening at the same time. So what you observe here, that it is getting shifted as well as getting shrinked. When you will see the final graph, that graph would be the graph when multiplied with 3. Then what will happen? It will get stretched vertically. So when you draw the final graph, what will happen? That it will be 3 times. So the value output here is 2. Now the new output will be 6. So it would be like this. And then the other output is 1. So it will be multiplied with 3, you will get 3. So it would go like this. Like this. 2, 3. And then you will multiply 3 to 2 again, then it will become 6. So it would be like this. So this will be the final graph which we are getting. So what is happening? It is getting shifted horizontally left. It is getting shrinked also. Then it is getting lifted upward vertically, and then you are getting the final graph. So this is the final graph here. And if you want to randomly check whether you are doing it correctly or not, you will just check it. How you will check it? For example, at x is equal to 2, you are getting 1. So what is happening here? That y is equal to f of x. You can say that at x is equal to 2, you are getting y is equal to 1. So 1 is equal to f of 2. Is that true here also? Let us see. So I am taking the value here minus 3 by 2 and I am putting in the place of x. So f into 2 into minus 3 by 2 plus 5 into 3. Let us calculate this. So 3 into f into, this would become 5 minus 3, 2. So 3 into f of 2. This is what we are getting. Now what is f of 2? It is 1. So this will become 3 into 1, which will be 3. So I am getting this value as 3. So if you see here, at minus 3 by 2, this point we are getting 3, of course. So yes, our graph is perfectly alright, which we have got. We can check for other points also. So this is the manner in which do this. We have to substitute the points here in place of the input and find the new x, and you will plot the points there for the new x, and then as per the requirement of the vertical shift or downward shift or vertical stretching or downward stretching, you can do that and you will get the final answer, students. So this was an introduction to transformation of graphs. There are a lot of more concepts here, a lot of details there. We can't go into all of them right now, and I hope you enjoyed this video lecture, and I hope that you will see more videos on Cube Live every week with new topics and more concepts, in-depth knowledges, and we will have more interaction with each other so that we would be able to come into some insightful conclusions also and some interactions also. Thank you, students.